students of mine in the room and also the online audience, welcome to the Microcontroller Design Lab and the RISC-V Community Challenge with HaDes-V. Welcome to the Kickoff event. First and foremost, why are we streaming this event? That's for both audiences, maybe important. This year's iteration of the Microcontroller Design Lab is featured as the official RISC-V International Community Challenge with HaDes-V. So Theo Graz is joining in there with RISC-V International to feature this event. Hold on real quick. To switch it on my end. So the next 20 minutes, roughly 20 minutes, I'll walk you through everything. So this is the Kickoff event. The Kickoff event itself provides information for the course, so for you in the room, for the students, but also for the community challenge. And you as students are also encouraged to take part in the community challenge. I come to this later as well. So we have on-site you guys, the Graz University of Technology students attending the Microcontroller Design Lab course. And online we have, I hope at least, there's numbers up to 500 participants from all over the world for the RISC-V Community Challenge. In the chat, as I last looked, it was like 100 persons online from all over the world, as Camille just said. And this is for you in the room. If you did not already enrolled, please scan that QR code to enroll in the official RISC-V Community Challenge, so you can partake in both. So you get a grade and also the certificate for the community challenge. I'm gonna put the slides online afterwards, so you can also enroll after the stream or the kickoff session. So, as I said, we have two audiences. That's why I decided to have a slide notation with 4 different emojis. The globe is for general content. The doctor's hat here is for Theo Graz course related only. So that's for the not that important for the online community. The puzzle piece is for the community challenge. And we have the wrench here for the technical content. And we're gonna notate it to the top right of our slide. So you see it always on your screen. Who are we? I didn't introduce ourselves. So my name is Tobias Schreiber, assistant professor here at Theo Graz and also RISC-V advocate. And with me is Florian Riedl from my group. And he's a PhD student. He will be the co-supervisor of this course as well. And we have 2 student tutors. Right in the back here is Simon Schiller and Michael Neubauer. So they will take care of your supervision of your questions, also for the online audience in the chat. So the rooms for the students, this is our building at Infeldgasse 16. We are in the first floor now in this room over here. We have 2 labs there. We have also 2 labs downstairs, and our offices are marked here as well. We're gonna get to that later on when we walk down to the lab to do all the stuff. As I said, slides will be online, so you can look it up later as well. But first, let me introduce you what we actually do within that community. We're building the HaDes-V processor. What is HaDes-V? HaDes-V is an open educational resource for microcontroller and processor design. And we're building a pipelined 32-bit RISC-V microcontroller in System Verilog. That's it, more or less. Sounds easy. We'll see about that. So what we do is we have a step-by-step modular jigsaw puzzle methodology. We're going to implement each of the stages separately, as I'm going to end, and we can validate it against pre-compiled golden references. What do I mean with that? So for each and every puzzle piece, we have a pre-compiled reference solution for you ready to check against. So at each and every time throughout the course, you will have the complete CPU ready to test. You can run software on it when working on the individual stages. We're, of course, not disclosing the solution to you. That's why we only give you the binaries. So it's a fully functional model, but you can use it to test your implementation. And secondly, so that was the local part. The remote part, we have an immediate feedback test system. So whenever you push onto your Git repository, which will be the submission system later on, you get a feedback from our test system with some errors you still might have, with some remarks that you should maybe work on. And you can also use GTK Wave locally to run waveforms to check what your solution actually does. So you can also see the waveforms, not just the behavior. Quickly to the learning objectives. So after the completing of the course, you will be able to design a complete modular RISC-V based microcontroller using system Verilog and standard development environments. So we're using VS Code here. Able to analyze the functionality and also the efficiency of different microcontroller designs using verification, synthesis, and also debugging tools. You'll be able to implement the different pipeline stages of a microcontroller using your processor architecture knowledge and hardware description languages, as I said, system Verilog. And you'll be able to explain the execution of software in process and evaluate their interaction with the hardware. You will not only implement that stuff, you will also present that stuff if you're a student. So let me quick go into the course organization. How does the course work here at TU Graz? So we usually start at 9 in the morning, downstairs or upstairs in the labs. And if there was a submission due, there will be a presentation session where the attendance is compulsory. Only after submissions, as I said, I will introduce the deadlines later on. We will have some discussion and also some questions, 2 to 3 of you, their last solution. And there will be a short introduction to the next exercise that will last around 1 hour, maybe 1.5 hours. And afterwards, we have a supervised laboratory where the attendance is voluntarily. So for you, compulsory attendance is only about 1 hour, not every week. Just check the schedule. In the supervised lab, you can work on your exercises on your own. You can take time to ask questions to me, to Florian, to the tutors, all the time, so they will be here for your question. And the room is booked until 1 p.m. About the grade, because I guess for you in the room, that's the most important thing. We have 100 of total points. It's split up in the practical part with 75 points. The tasks build on each other, so subsequent errors are unfortunately also included in your evaluation. What does that mean? If you have an error in your previous submission, fix it afterwards as well. And as I said before, we have an automated test system, and that also takes care of the grading. So you will at every point in time know how many points you just have. You can max it up until the deadline, and the points that the test system shows at the deadline will also be the points that you will get for that. For that, you have to check the Persephone branch of your repository. So when you set up your repository, Persephone will hook in, create a repository, and put the grades there. The second thing is the presentation part. As I said before, whenever there was a submission due, there will be a presentation session afterwards, 2 to 3 presentations per person, some general questions, and the points will be published in the Teach Center afterwards. Okay, organizatorical stuff is done. So how do we start now? Yes?
I have a quick question regarding the subsequent errors. If
Yeah.
you make an error in part 1, for example,
Yeah.
the deadline is over,
Yeah.
given it,
Yeah.
we still have time to correct
Yes.
part 1 and 2, 3, 4?
Yes. That's not a problem. Okay, so how do we start now? I'm going to give you a short outline. First thing, join the communication channels. Second thing, set up your repository if you have not done so. Third thing, look into the instruction guide. And the fourth thing is download the virtual machine that we provide with all the tools pre-installed and try stuff out. As easy as that. I'm going to go through all the 4 parts now. Communication channels. You might see there is a matrix chat hosted by TU Graz, and we have 3 different channels: the community challenge channel, we have the discussions channel, and also the announcements channel. The announcements channel is only for official announcements for the course participants. The community challenge channel is for organizational stuff within the community challenge, and the cool stuff is here in the discussion channels. Every participant of this year's iteration will be present. You can discuss their technical issues, so don't be shy. You can also ask for help in there. That's pretty much self-organized, so I'd like you guys and also the online participants to take care of that channel by yourselves, help yourselves, and if there is really something going on that you cannot, as a community, solve, then you can reach out to the tutors. So actually, it is kind of nonsense. Of course, we will be there as well if things go off, but try to keep it within your HaDes-V bubble, I'm calling it now. Okay, so much for the communication channels. Next, setting up your repository. We have provided a source code template for you. The source code template is on GitHub. You'll see that link up there. It's also in the instruction guide later on. And now for the TU Graz, people create a repository in the TU Graz GitLab and add those 4 people, so exactly the ones that I introduced before, as maintainers, so we can also have a look at your code and, if needed, also edit your code. All the other roles are unfortunately not good enough, so we need the maintainer role. For the international crowd, you can use GitHub if you want. It's very important to set the repository to private. We will also check it. If the repository is not set to private, Persephone won't grade your stuff. So that's the thing. If you want to partake in the challenge, set your repository to private. That's just so other people cannot cheat. You cannot cheat. We want you to learn something and not just harvest code of other people. And within here, you need to add collaborators. So we need to be equals here. And I've put 3 GitHub links to profiles here. That's my tutors. Please add us so we can also access your GitHub repository if you want to use it. And if you want to have it hosted somewhere else, so either, I don't know, a public GitLab or whatever, please individually contact me. I've put my private email address here, set read and write access to that, and also make sure that the repository is, so it does not matter where you store your Git repository, it is just important that it is a Git repository and that it's set to private. Okay, so much for setting up your repository. The next thing, where to start reading. So as I said before, the HaDes-V is an open educational resource. So we have a DOI for our instruction guide and all the other material. So the first step would be download that instruction guide and have a look. Instruction guide features the toolchain preparation if you want to set it up by yourself. Small hint, if you download the virtual machine, the link I will show afterwards.
I think this is an important question. Creating a fork is always public. So it's about using the template, not necessarily creating a fork.
Yes.
Yeah.
Yes.
So just maybe clarify that.
So if you create a fork that's always public, that might be an issue. That's true. We didn't. So maybe just clone the template. So there's a template button that says use the template and create your repository this way. If you have already sent your repository link before, that should not be an issue as well. Just re-invite the people and then we get going. So don't, that's not a problem at all. That's why I would like to wait you until the creation of your repository, until this kickoff. But now I think we've set it up. Thanks for the question from the online audience. Okay, so back, toolchain preparation. The toolchain is already prepared in the virtual machine. The link will be posted later on, but you can also set it up natively in, for instance, your own Linux distribution, or also in WSL if you really want to, that you can do. The next thing, the next chapter is the getting ready chapter. There are some GitLab specifics included, but it also includes the make field, some description about the synthesis, and also how to upload software to your microcontroller that you design. And most importantly, it also contains the introduction to the exercises. The introduction to the exercises shows which part of the MCU or the CPU you need to design for which exercise. And the major chapter within the instruction guide is the HaDes-V architecture description. That is what you actually have to do. And as you might see, the description is quite short. We have a lot of cross-references. As we are implementing a RISC-V CPU, we're having a lot of cross-references to the actual instruction set architecture specifications. So you might click yourself through, get yourselves familiar with the RISC-V instruction set architecture, because we're doing standard stuff here. We're not doing some proprietary thing. We're really doing a RISC-V a standardized RISC-V microcontroller. Okay, so much to the instruction guide and the other material. For the exercises for the lab, this is the preliminary schedule. You can have a look at the Teach Center. I put the link there as well. And as you see, next week, there's already the first deadline for the CPU, but don't be afraid, that's a very easy. Also, the online audience must not be afraid. The CPU, so exercise number 1 is very easy. It's just connecting modules, more or less. Should be a piece of cake if you're familiar with some hardware description languages. But for the offline folks, so for you students, it is important to mention that the deadline for the submission is every Sunday before the presentation session at midnight. And we take the Git log. So our test system uses the Git log for the have not commit until midnight. Yeah, that's your bad then in the end. So lab sessions are on Tuesday, March 10th. Sunday before, March 8th, midnight is the deadline. And be aware that you will get a grade after the first submission, so March 10th, if you're still registered and you did a submission. Submission is every action you take. For instance, creating a repository, pushing files, your signature on the attendance sheet, and so on. Attendance sheet will be handed out later. So that's very important. If you, until March 10th, realize that you don't want to partake in that course, please deregister as well. Otherwise, we have to grade you. Okay, for the community challenge, what are the challenges exactly? So we have a 3-stage or 3 medals, as we are in the Olympic spirit still. The bronze medal is for completing exercises 1 to 3. So it's only 3 exercises that should be quite easily achievable. The silver medal is for finishing the simulation transfer phase. So that's all the other exercises until the microcontroller is completely done, but still not on hardware, only in simulation. So everything you need until you really need the hardware is for the silver medal. And the gold medal is afterwards we are creating a in-person workshop, hopefully somewhere. There will be one here for sure, and there might be some other workshop that's still in a secret location, but I'll get to that throughout the course. And it's maybe important for you as well. Bronze, silver, and gold medals will be mapped into so-called Credly certificates. So that's certificates that are issued by RISC-V International and the Linux Foundation that you can use for your CV, that you can use for your LinkedIn profile. They are really personal certificates that you can use to show that you have skill in creating RISC-V microcontrollers. So that is the cool thing if you as a student also participate in that, because then you get a grade and also the certificates. For the online folks, unfortunately, there's only the certificates because I cannot issue our university. That's the thing. So for the deadlines for the community challenge, the first or the bronze and the silver medal are due until May 31st, and the workshop date will be announced throughout the first phase. It will most likely be mid-June, but we'll announce that once we have time and location for that. Okay, so I've said that you should lastly download the VM and try stuff. Downloading the VM and trying stuff, I fear that that link is broken, but there is the correct link in the hub and also in the Teach Center. I will come to that later. So download the VM, clone the repository that you created, including the code template. So use the code template as Florian pointed out, not just fork it. Open VS Code, navigate to the repository, and execute make help and play around with the make commands a little bit. Make help shows you what the make files are capable of. So that should be your first step. Try out what is there already. And if you are common with the makefile environment and also with the code environment, then you can open the CPU.sv file in the RTL folder, remove the line ref_CPU golden, which is the golden reference, and get started implementing your stuff. That's everything you need to do all the time. So in every code file of the template repository, there will be the golden references initiated. That's what I initialized. That's what I meant before. That's our pre-compiled golden references. Remove that line, start coding. And maybe an important side mark at the end, read. So the instruction guide has a lot of cross-references, a lot of information that you should bear in mind. So please take a moment, take a step back, read your stuff, and only afterwards start with the actual coding. Once you started coding, don't forget to push on your Git repository, and then you can observe the Persephone branch of your repository. What do I mean? There will be a file then that you can look at. That's, for instance, the styled markdown file in our GitLab instance, where you can see your test case results. You see the repository name, you see when the test was run, you can see for which deadline the test was run, you can see the commit information, and down here are the results of your test. For instance, it could look like this for a fetch stage. Yeah, some delayed wishbone acknowledges in there, and you have your implementation has this value, but expected there was another value. Please notice that if you commit stuff which is not functional at all, Persephone will also not immediately start giving you all the errors. You will have to cross a threshold until Persephone really shows you what's still missing. This way we want to avoid that you hand in empty functions and only start benchmark engineering. That's just a side note here. So if you're wondering why Persephone did not start putting stuff in your repository, it might be because you have too little points as of now. Okay, so I have 3 more slides, I think. One is for the students. How do we start in the lab now? The group registration started 10 minutes ago, but it's only organizatorical. We have 4 total groups of 6. I think we're too many people as of now. I will add some more, so just register for the wait list. Groups 1 and 2 are downstairs. Group 3 and 4 are upstairs. Please distribute evenly. And after that, you can follow your tutor to the lab room according to your group. In the lab, the machines can also be used. The VMs are pre-installed there. And yeah, if you're down there, simply download the instruction guide and start reading. And if you haven't registered for the challenge yet, here is the QR code again. So also for the challenge participants, please make sure that you are officially registered. Then create and set up your repo. You know who to add. Download the instruction guide and start reading. Reading, not coding yet. Please really take your time, read through the stuff, and only then start coding. I have 2 more information QR for you. The one is, so the one to the right is the information about the community challenge, where you can RSVP and register officially. There is also a lot of information going on there. There's a lot of links there also to the instruction guide, the VM, and whatsoever. And the material hub on my private homepage is to the left here. So you can open that. Also, the YouTube video for the introduction is linked there. Scientific papers that we published, all the material that we used is on there. So that's a very, very wide site where a lot of links are on there. You can take some time and read through that and have a look at all the material that's posted there. As I said, the slides will be online, both actually at 3 points. It's in the hub, it's on the community page, and also in the Teach Center for the students. Okay, that's it for now. If you have further questions, there is time for questions now. But you can also, if you want, simply ask in the chat or your tutors afterwards. So thank you for now. And if there are questions, please let me know. Maybe also in the chat.
The recording is available where?
I will send out the link. So the recording to the to this event now. So we streamed and recorded that. It will be Camille. You can maybe help me with that. I think it will show up on the Bevy page, right?
Yes, Megan will add it either later today or tomorrow.
Okay, perfect. So it will be added today or tomorrow on the community challenge page. And maybe a small remark: if you have not registered yet, there's time until 3rd of April, as far as I know. So there's still plenty of time to enroll in the challenge if you want to partake. The list of exercises is available for the international audience in the instruction guide. So the instruction guide features the entire list of exercises that's interesting for both the online audience and also for the students in here. Thanks for pointing that out. I was not very explicit for that. Also, the setup on the local machine is explained in the instruction guide. Okay, but if the students have no questions as of now, please register for the groups and then afterwards follow the tutor that is assigned to your group downstairs or back to the labs, and we'll set up things. Okay, thank you. And I'll stay online for the online audience a little bit. Flo, magst du kurz die Labs aufsperren? Okay, so there was a question about whether or not you'll be able to do the challenge in a group. Essentially, it is a individual work, so groups are not what you want to do here, but you can enroll with your friends as well and talk about it with your friends, but please set up individual repositories because we cannot award the certificates for groups. We can only award it for individuals. Yes, you of course can carry on the work beyond 31st of May. That's just the deadline for awarding the certificates. That's pretty much it. The offline workshop, we still don't know. As I said, we'll get to that later. The guidelines concerning the Git repository should follow the structure that's in the template, so use the template on GitHub. To be very honest with you, Vignesh, it is not very easy for non-Verilog background, but if you have some background in hardware description languages, you can catch up. So we have some people that have no background in system Verilog, but a little bit in hardware description languages, and they usually, that works out just fine. Yes, you can resubmit the repository as well. Just invite the people that are mentioned on the slides. Yes, it is easy to transfer from Verilog to system Verilog. That's for sure. The most of the synthesizable code will look quite familiar, I would say. Yes, there is a list of collaborators. Please have a look in the slides. There's 3 GitHub accounts to add. Yes, that seems correct. Yes, you have to complete the list of exercises and they are graded. automatically in Git. That's correct. The slides are on the Material Hub and also linked in the Community Challenge page. The meeting is still being recorded, and we'll post the link on the Community Challenge RSVP page afterwards. With respect to Learn material, it is available online. Just check it there. There's also a RISC-V book about it if you really need it, but the online references are the best. Yeah, in the materials you find the exercises. That's it. The collaborators have not yet accepted your request from Git. That is correct, because we did not. We wanted you to wait until we kick it off, and only from beginning of now we will start adding the repositories, and then we move. The hours expected will vary a lot individually. It depends on what you bring to the table. So I cannot give a number here. The difference between HaDes-V and RISC-V. RISC-V is an instruction set architecture, as you should know, and HaDes-V is in CPU, so a central processing unit that has this instruction set architecture implemented. Yes, you have forked the HaDes-V repo, but it hasn't got the Persephone branch because we are 1 hour into the challenge, and the collaborators did not have time to add your repository as of now. Please be patient. Everything will work out in the end. Okay? We will work on a way on how to award the gold badge also for the online audience, but we're still in negotiating it, but that might take some time still. So if you ask the questions in a couple of weeks, then I might have more information. I'm very sorry about that. If you have zero experience with hardware design, but lots of experience as a software engineer, the best starting point might be having a look at System Verilog tutorials, some easy hardware designs, and then you can, from then, have a look at Verilator. Verilator is a simulator for for Verilog and System Verilog, so you can use that and start from there. I think that's the easiest way. The learning material for what you need, we will provide everything that's in the Material Hub. We are not a System Verilog course, we are a processor design course. So hardware description languages is presumed within that course. Everything is RISC-V. So RISC-V is everything. HaDes-V is a RISC-V core. Yes, you can also add your custom instructions afterwards, but first I will ask you to implement what you have, but you will see that in adding instructions to the execute stage of the HaDes-V processor is quite easy. Yes, it is a complete design and verification of a 32-bit RISC-V. So you will create a 32-bit RISC-V core from scratch. What are your doubts? And yes, the design of the pipeline will be covered in this course, of course. The use of AI tools, interesting question. I don't think that AI will help you here. AI is pretty good in code generation for Python, maybe also for desktop PC, stuff like that, but it's not very good for hardware description languages. Not really recommend you doing so. You can try if it helps, but I fear that it makes things even worse. Yeah, you can use Questsim or Synopsys as well. We're using Verilator as we're using open source tools for that. You can contact the instructors in the chats. When you add the organizers as collaborators, we will hook your repository into Persephone, and then Persephone will create that branch for you. So please be patient, and then you'll see how things will work out. Of course, you've never used Persephone because it's our own creation. Of course, you don't have to stay. Please feel free to leave the chat room. I will still stay online a little bit to answer more questions. They will be recorded, so you can also step by afterwards if there are still open issues. Yes, so Persephone will take care of the main branch only for testing, but I don't think that you really need branches. Yeah, you can use the tools locally also, but if you want to have the same results as our test system, also use the version numbers that we provide in the instruction guide. That's pretty much it, but that's perfectly fine, yeah. So if you have made the GitHub repo and shared the collab link, then you can start coding, reading and coding, as I said. Licensing limitation, what do you mean with that? Xilinx Vivado is not an open source EDA tool, but for synthesis, using it anyways. But that will be only done in the hardware workshop in the end. How to add collaborators on GitHub? Please Google that. That's not easily to verbally say. Please Google it. There's plenty of instructions out there. That you mean. Yeah, so HaDes-V is licensed under MIT license, the code, and the instruction guide is licensed by Creative Commons attribution share alike license, so you can adhere to these licenses and do whatever you want with it afterwards. That's not a problem at all. That's highly permissive licenses. That's perfect. So if you have forked it, I think you have to create a new one because you need to use the template for a private repository. That's what the way is apparently. GitHub is not that easy with that. So yes, the recording will be on the page. We're still recording, by the way, so all you ask now is recorded. Collaborators are in the slides. as I said in the slides, 31st of May is for bronze and silver medal. You don't resubmit the Git link, you just add the collaborators, that is enough. Yes, that's we already forking makes it public. That's why you don't fork, but use the template. That's the difference. Okay, guys, I'm iterating over the same questions all the time. I think I answered the question about private and public repository. So once more, do not fork the template. Use the template. There's a button. And then you can also set your repository to private. No Persephone is not available to the public unless you are a university.